The public is increasingly concerned that heavy applications of salt to roads will shorten the life of vehicles and the highway infrastructure, and possibly contaminate water supply. Some areas have restricted or even prohibited the use of salt on their road systems. Michigan banned salt on the Zilwaukee Bridge. Madison, Wisconsin has established limits on salt usage for nearly 20 years. States, including California and Massachusetts, reduced salt usage through anti-icing and pre-wetting procedures, as well as substituting calcium magnesium acetate for salt and using abrasives. Because of potential adverse effects of chemical de-icers, highway agencies must take care in selecting salt, new chemicals, or improved salt formulations. However, Transportation Research Board Special Report 235, released in 1991, concluded that because of economic considerations, salt will continue to be the predominant de-icer for many years. There is hope. New products such as sodium formate and magnesium chloride and reformulations of old products have entered the marketplace. Unfortunately, transportation agencies lack standardized test procedures. They need methods for objectively evaluating the effectiveness of various materials and predicting their impact on the environment. To help, Sharp has developed a set of 12 simple and inexpensive tests that highway agencies, as well as manufacturers, can use. They're detailed in a manual titled Handbook of Test Methods for Evaluating Chemical De-Icers. Researchers identified 8 important characteristics that should be considered when evaluating and selecting de-icers: physicochemical characteristics, de-icing performance, compatibility with bare and coated metals, compatibility with metals in concrete, compatibility with concrete and non-metals, engineering parameters, ecological effects, and health and safety aspects. Each of these 8 characteristics is addressed by one or more of the 12 primary tests, or 50 existing standard tests listed in the handbook. This presentation will give you a brief look at each of the 12 primary tests. It's not intended to show every step in the tests. The 12 primary test methods include 2 tests for ice melting capacity, 1 for solid de-icing chemicals and 1 for liquid, 2 tests for ice penetration, 1 for solid and 1 for liquid de-icing chemicals, 2 tests for ice undercutting, 1 for solid and 1 for liquid de-icing chemicals, evaluation of corrosive effects of de-icing chemicals on metals, rapid evaluation of effects of de-icing chemicals on concrete, evaluation of scaling effects of de-icing chemicals on concrete surfaces, evaluation of frictional characteristics of de-icing chemicals, preliminary assessment of ecological effects of de-icing chemicals, and evaluation of corrosive effects of de-icing chemicals on steel reinforcement in concrete. The first 6 primary tests are conducted in a cold room at a controlled temperature or in a special freezer. 2 of these tests evaluate the capability of a de-icer to melt ice. The first test method covers solid de-icing chemicals, and the second, liquid de-icers. They are simple tests. For these tests, place a measured amount of water in a plexiglass dish. Once it is frozen and smoothed, apply a measured amount of the chemical, solid or liquid. Then periodically measure the melt volume to determine how much ice has been melted. Return the liquid to the dish. Run this test at various temperatures to determine what effect temperature has on the de-icer's ability to melt ice. The next 2 primary tests evaluate penetration of ice by a solid or liquid de-icer. The test uses an acrylic plastic plate with holes drilled in it. After filling the holes with water and freezing it, place de-icer on top of each column of ice. Blue dye is added for visibility. By checking the penetration depths at predetermined time intervals, you can determine a penetration rate for a series of temperatures. 2 tests measure a de-icer's ability to undercut and destroy the bond between ice and pavement. They use a mortar or asphaltic substrate representing the pavement. Again, one test covers solid de-icers and the other liquid de-icers. After freezing water and smoothing it to a uniform 1/8 inch thickness, apply the de-icer and then measure the melt area at the interface of the ice and the substrate. To map the melt area, take photo slides of the substrate, project them, and outline the area on paper. Then divide the total area by the weight of the de-icer. This gives you an area undercut per unit weight of de-icer. Another test evaluates a de-icer's corrosive effect on metal. Prepare a test cell with an aerated de-icer solution. Then place metal test specimens in the cells for various lengths of time, from 1 to 8 weeks. After removing the specimens, cleaning and drying them, weigh and inspect each to determine the rate of corrosion. This method is also good for testing corrosion inhibitors. Another test uses small specimens of non-air entrained concrete. After saturating sponges with de-icer solution, place specimens on the sponges and put them through 10 freeze-thaw cycles. Each cycle lasts about 24 hours. At the end of the last cycle, wash, dry, and weigh the samples. This test evaluates de-icers for scaling effects on concrete surfaces. Make a rectangular concrete specimen and then pour a solution of de-icer into a reservoir on the top. You should subject this specimen to 5 freeze-thaw cycles, each lasting 24 hours. Next, wash the specimen and weigh the residual solids. Then repeat the entire procedure for as many as 50 cycles. You should make a visual evaluation and rank the specimen after each 5 cycles. Another test measures the frictional characteristics of de-icers. Put de-icer on a clean sandblasted glass plate. Then, using a British pendulum tester, swing the pendulum, allowing the rubber shoe to slide over the wet surface. You should conduct the test 6 times, re-wetting the test area each time, and record results after each swing. The British pendulum tester measures frictional properties as a British pendulum number, or BPN. There are 2 ecological tests, one for acute and chronic toxicity in an aquatic system, and one for seed germination. For the aquatic test, place several fish species in a flow aquarium containing de-icer solutions at various concentrations. Beakers can be used as an alternative to the flow aquarium. For the acute test, determine the LC50, or lethal concentration, based on the 24-hour mortality rate. For the chronic test, run the test over a 7-day period with the solution replaced daily. For each concentration, note water quality, including pH, dissolved oxygen, and conductivity, as well as the mortality rate of the fish. Construction details for the flow aquarium are included in the handbook. For the seed test, you should choose 5 seed plants typical of your geographic area. Place the seeds on 2 sheets of filter paper in a test container. Then add de-icer to the container and check it over a 5-day period. After 5 days, note which seeds have germinated and their size. The last primary test evaluates the corrosive effects of de-icing chemicals on steel reinforcement in concrete. It is conducted by measuring the voltage across a resistor between 2 bare steel rebar mats and calculating the current flow. Subject the macrocell specimen to alternating 2-week cycles of ponding with selected de-icer solutions, followed by drying. To monitor the corrosion rate of the rebar, measure voltage across a 100-ohm resistor at the beginning of the 2nd week of each ponding cycle. Monitor the current as a function of time by number of cycles until you note a difference between the reference and the de-icer solution samples, or until some set shows visible signs of corrosion. When the test is done, break open the specimen and check the rebar's appearance. Sharp developed these 12 tests to evaluate de-icing chemicals. The tests are simple, inexpensive, and straightforward. State highway agencies can use them to assess new product offerings. Industrial suppliers can use them to guide their product development and to develop marketing information that addresses state concerns. These tests are now being considered by AASHTO for adoption as standards. You can find out more about each test method in the handbook, Test Methods for Evaluating Chemical De-Icers. It describes in detail the 12 primary tests and lists an additional 50 ASTM and EPA tests, which might also be considered in comparing different chemicals. It's available from the Transportation Research Board, TRB.